to you. Okay, we're recording now. And let me, let's see, share the screen. Sorry, this always takes a while. Okay, first order of business is leading up to the next exam. Okay, so this is our schedule. We are here. So again, all of this is moved up a day. So 6.4 today. I'm actually going to sneak in some of 6.5. I do want to go over that table, at least see it once. If I wait until Tuesday to show you that table, then you only have 2 days to prepare for it. So I thought I'd finish 6.4 rapidly and then go to 6.5. That being the case, for most of the calculations, I will not show you, I won't punch it out on the calculator like I did before. You'll just have to take my word for it to save time. I will assume you can punch it out on a calculator. I'll just say, blah, 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 do this. And the answer comes out to be blank. And I will assume you can do that a little bit later. So I'm going to do 6.4, sneak in a little bit of 6.5, and I'm going to go over that spreadsheet. Okay, and then 6.5, I'll do more of that. Exam is now next Thursday. Okay? So if I finish early enough on Tuesday, I'll let you ask questions. Okay. And even on the day of the test, you can ask questions for the first 20 minutes, but if you don't ask any questions, then we can just start the test a little bit earlier as normal, okay? So that's what's gonna happen there. All right, so I'll get started from here right away. Okay, next thing that I wanna go over is actually to all of you, and I don't really know who is involved with all this, but I'll just go ahead and show you. I got this, a headset. I'm going to try it out for the first time today and see if it works. And it may very well be you folks, because whoever sent it to me in the mail, this is what it says. To Prof. Melham, your CCSF math students, thank you for everything. Okay, now I don't know if this is this semester or last semester. If it's this semester, you guys did it pretty fast. Okay, and you got it to me. So if you were part of it, thank you. If you have no idea what I'm talking about, that's okay. Thank you anyway. I mean, there's no names attached to whoever it was. So if you were part of it, thank you. Or if you want to tell me later you were part of it. But this is it, okay? And supposedly, I guess you did it to help with the audio. So I'm testing this out for the first time. So I may need you guys' feedback on whether this is good or not. So I guess I got to do this stuff. I'm not really comfortable with this, but be that as it may. Because to me, this kind of looks like I'm a salesperson or, advertiser trying to sell something, or somebody answering the phone and all that stuff. Okay, so bear with me as I set this up and go like this. And plug this thing in. Okay, I'm using it now. Can you sort of give me a feedback on whether this is better or worse than before? So can you just type something in the chat, better or worse, or, okay, big difference I read. Okay, so.
It sounds better.
This is better?
Better, and I can hear you clearly.
You can hear me clearly, okay. I think that's good. So better, no more static. Somebody says worse, somebody better. Okay, some of you actually say worse, some of you say better, but the majority seem to say better. And this is too loud for me now. So how do I turn down the volume? Maybe I go like this. Okay, because I can't hear myself too. And I can hear you folks better too. I guess that makes sense, because instead of talking through the air and listening to you on the air, I can get it straight through the machine here. Okay, so hopefully this is better. But now I'm kind of stuck to this, so I can't reach out as far. And I keep hearing myself. But it's a nice experiment. So if you folks gave it to me, thank you. If you have no idea what I'm talking about, well, thank you anyway. It's nice for you to do that. Okay. All right, so I'm going to get started. So hopefully this makes things a little bit better for all of us. Okay, for the assignment, again, just like last time, unfortunately, I'm changing it because of the edition of the book that I had. Originally, it was 3 to 10. For the edition that I have now, it's changed to 5 to 12. Okay, again, it doesn't really matter which edition of the book you use. Okay, look at the problems I do. Use the problems as a template for the problems that you have. And when you turn in your homework, again, it doesn't really matter which edition did you have. You're still learning the material. And I mean, that was borne out from the first test, right? Some of you have my book, some of you have a different edition. You still were able to be okay on the exam for most of you. So just do the same thing. Okay, and I'm hearing an echo of myself, so I'm gonna turn myself down. But okay, now if you can't hear me, let me know, or unmute yourself or put it in the chat. But I seem to hear myself too much. But maybe that's a way the machine works. Okay, so again, I'm changing the assignment to 5 to 12. Okay, so 6.4. Here are the problems. 5, 6, 7, 8, 9, 10, 11, 12. Okay, if you want to just look off of the book from earlier. Okay, and here is the one formula. Did you want to put it on your formula sheet? It's called the present value of an ordinary annuity. A sub n, called the present value, is R. That's a periodic payment. And then 1 minus 1 plus I to the negative n all over I. Okay, so that's the formula. I'll just talk quickly about what's the difference between this and last time. Okay, so this time, again, you're putting down a big lump sum. That's the A sub n. So suppose I go to the banker and say, here's $100,000. Okay, make my money grow, but you're making periodic withdrawals. So you are regularly taking money out, and you keep doing that until it's all drained out. Okay, so that's what's happening in this particular case. Okay, so a big lump sum, that's called the present value. You make periodic withdrawals. It might be payments also. Okay, but all along you're earning interest. Okay, now the I and the N are the same as last time. It's periodic. Okay, so you take the interest rate and divide it by 2 if it's semi-annual, divided by 4 if it's quarterly, divided by 12 if it's monthly, and so on. And N again is a total number of compounding periods. Okay. All right. So in order to save time today, I will not show you myself, typing everything in the calculator. I'll trust you can do that on your own, and we'll just go right to it. Okay. So here we go. Okay, so 6.4. Okay, number 6, find a present value of an annuity that pays $3,000 at the end of each 6-month period for 6 years. If the interest rate is 6%, there's a lot of sixes there, compounded semi-annually. Okay, now I'm going to put the book down, but if you didn't see that, I got all the data right here that we need to use the formula. Okay, so the periodic payment or withdrawal, as it is $3,000, 6 years, semi-annual compounding. Okay, so you should know how that works. 6% semi-annual means I is 0.03. Okay, 3%. Turn the volume of myself down a little bit more. I can. And what's N? 6 years, 2 times a year. 6 times 2 is 12, right? And then I just throw it into the formula. Okay, and maybe I'll write the formula off to the side here so I don't have to keep referring to it. AN equals R, 1 minus 1 plus I to the negative N over I. Definitely put that in your cheat sheet. Okay, but the same strategy, semi-annual, divide by 2. N is 12, 6 times 2, 6 years, 2 times a year. So 3,000 goes there, 1 minus 1.03 to the negative 12 divided by 0.03. Okay, and again, this time, to save time, I'm not going to punch it in a calculator, but you can try it. It's $29,862.01. Okay. So you can try that on your own. Make sure you can punch this on your calculator. And as normal, if it's a money thing, always round to the nearest penny. Okay, so supposedly when you punch all this out, that's what you get. Okay, I'll just mention off to the side, what this means is that if I go to the banker and I say, here, banker, here's $29,862.01. Okay. I'm going to be able, under this scheme, if I'm earning 6% compounded semi-annually, I'll be able to withdraw $3,000 12 times every 6 months. Okay, so what's the total amount of the withdrawal? I'm digging deeper. Well, I can take $3,000 out 12 times, so I withdraw $36,000. I put in only $29,862.01. I get to take this much out. That's because it's earning interest, right? So I put in this amount, it earns some interest, but then I withdraw $3,000 every 6 months. It's earning interest. Withdraw another $3,000 every 6 months. It's still earning interest. So under this scenario, I will be able to withdraw $36,000 total dollars. So as you can see, it's nice to earn interest. Okay, so it's a little bit different than last time. Okay, when we said the future value of an ordinary annuity. Okay, so last time it was called future value. You put down $500 every month and let it grow. Here you put a big lump sum down and make periodic withdrawals. Okay. All right, so that's how that works. Okay, then the next one was number 8. How much is needed in an account that earns 8.4% compounded monthly? Aha, monthly means I'm dividing by 12 in order to withdraw $1,000 at the end of each month for 20 years. Okay, I got the important data here. All right, so 8.4% compounded monthly, 20 years. How much do I plunk down right now? It's a big lump sum in order for me to do this, to withdraw $1,000 every month for 20 years. Okay, so I take this 8.4% and divide it by, hint, it says monthly, divide by 12. So 8.4% is 0.084 divided by 12, it's 0.007. Okay. And now what's the total N? Okay, 20 years, monthly. That means times 12, right? So 12 times 20, N is 240. Okay, so N is 240, that goes up there. The I is 0.007. Throw it into this thing. Okay, so AN is 1,000 times this great big 1 minus 1.007 to the negative 240. Be careful, in the formula, it's a negative exponent divided by 0.007. Okay, and if you punch it out correctly, $116,076. And to the nearest penny, it's 0.00, it looks like. So that's called the present value of the annuity. So if I deposit this big number, $116,076, and if I earn this much interest, they promise me, whoops, where'd it go? 8.4% compounded monthly, I'll be able to take out $1,000 a month for 20 years. That's what it means. And just digging deeper, what's the total amount of withdrawals? Well, I get to withdraw $1,000 each period and 240 times. Well, the math is easy. 1,000 times 240 is $240,000. You can see the big power of compound interest. Okay, I deposited this much. I can take out this much. It looks like it's more than double, right? More than double for the total amount. Okay. And let's see the next one. It's a little bit different. Just 10, 88,000 is invested. Okay, that's the A sub N. That's the left-hand side of the equation. Okay, that's the present value of an annuity. It earns 5.8% compounded quarterly. Okay, so you should know what to do with quarterly, right? Quarterly means divide by 4. what payments will it provide at the end of each quarter for the next 5.5 years? So to find n, I take 5.5 and multiply by, again, it says quarterly, so multiply by 4. Okay. Okay. And sorry, the numbering is off. This was from the old edition, but I'm doing the right problem. So A sub n is 88,000. 88,000 goes right here. And that's actually the style of the next section, our last section, which is 6.5. Okay, where a lot of times you're going to be figuring out the R. So 88,000 goes here. I was 5.8% is 0.058 divided by 4 because it says quarterly, right? Punch that in the calculator, 0.0145. N, okay, it said 5.5 years, so 5.5, multiply that by 4, 22. Okay, so 88,000 equals R times this mess, 1 minus 1 plus I. So it's 1.0145 raised to the negative 22 divided by 0.0145. Okay, that comes out to be about 18.72. And here's another case where you want to use your answer button, A and S. And if you don't have that answer button, like if you only have a calculator like this, then sorry, you folks would have to actually type out every single digit that's there. Okay, and yeah, I think I'm willing to do it for this one. Okay, so let me spend the time to actually figure out the exact value of that. Okay, so on my calculator, I'm doing 1 minus 1.0145 raised to the what? Exponent is negative 22 divided by 0.0145 is 18.72. So here's what I typed. 1 minus 1.0145 exponent negative 22 divided by 0.0145. 18.7212094211. Okay, so I will use this answer button. Okay, so how do you solve for R? Divide by 18.72, blah, 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 blah. Okay, the next section you'll be doing quite a bit of that. So the shortcut is to hit 88,000 divided by answer. So my answer button is right here on my calculator. I see a lot of calculators that have that, right? So second function, answer. So if you look at my calculator, it says 88,000 divided by answer. When I type answer, it's just like I type 18.7212094211. And there we go. 4700.551 means 4700.55. And there we go. Okay, again, if you don't have that answer button, it's only a little bit harder for you folks. You might have to write it down on your paper. And then you folks, I'll actually do it so you can see what it did. You would actually have to go 88000 and then divide it by every single digit. 4700.55. It's to get greater accuracy, right? 551017. 5. Okay, and you get the same answer, of course. All right, so you just have to, watch out for that. Okay, again, a side note, what's the total amount of withdrawals? So 4700.55 times 22 is $103,412.10. So I put down 88,000, I get to withdraw 103,000 something. Okay. All right, then the last one of this type of problem that I wanted to show you is a little bit harder. Number 12. Okay, a professional athlete invested $2.5 million in an account that earned 6.8% compounded semi-annually. So you should know what semi-annually means. I'm doing number 12. If 120,000 is to be withdrawn at the end of each 6 months, how long will it be until the account balance is 0? Whoops. Check this out. I knocked off the thing, so let me see if I can get it back. You see, I've got all these wires here. Okay, so what am I supposed to do? Go back to share screen, see if I can get that back. Okay, back in business. Okay, so this athlete has $2,500,000. Okay. He or she wants to withdraw $120,000 every 6 months. How long can he keep doing that, or she keep doing that until it's all drained? Okay, so that's again. In the meantime, earning 6.8% interest compounded semi-annually. Okay, so this athlete deposits this much money, 2.5 million, earning 6.8% interest compounded semi-annually, divided by 2. And they want to withdraw 120,000 every 6 months. How long until the account is drained? Okay, so I is 0.068 divided by 2, which is 0.034. Okay, we know the AN, 2,500,000. We know the R, 120,000. We know the I, 1 minus 1.034 to the negative N, we don't know that, divided by I, 0.034, plugging into here. Okay, so right now it's this, 2,500,000 equals 120,000 times that funny looking fraction. Okay? By the way, on a test or quiz or homework, show me all your work. That way I can give you partial credit. Okay, so you should show me, when in doubt, show as much as I'm showing you right now, I guess. That's the way to say it. Okay, divide by 120,000. I did it before. This is 20.83 repeating. Are you familiar with the bar? The bar means repeating. It's 20.833333 if you divide that by that. Okay. And that's gone. I have 0.034 on the bottom. To get rid of that, multiply both sides by 0.034. And sorry, I'm going to try to lower the volume some more on me. So I see when I'm doing this thing, I kind of hear myself, or a little bit of an echo, but whatever. Okay, multiplied by 0.034. That times that is now 0.0783 repeating. That cancels out. 1 minus 1.034 to the negative N. Okay, subtract 1 on both sides. So minus 1, minus 1. 0.29, sorry, negative 0.2916 repeating is negative 1.034 to the negative N. They both have negatives, but just multiply both sides by negative 1 and they become positive. Okay, so now the equation looks like this. Positive 0.2916 repeating is 1.034 to the negative N. Now, how do I get that negative N down? Take the natural log of both sides. So you ln both sides. Let me raise it up. Okay, and yeah, let me raise all of this up in case you want to look at the video later. Sorry. Yeah, I actually wish my document camera had a focus button, but it doesn't. So the only way I can do it is to raise it up, but I can't raise it up indefinitely. So I know I'm running through this kind of fast, but I'm sorry, you can look at the video later, of course. Okay, so now the negative N gets to come in front. So now it looks like this. ln of 0.2916 repeating is negative N natural log of 1.034. Divide both sides by negative ln 1.034, negative ln 1.034. Okay, so on your calculator, hit natural log of 0.2916 repeating. See, how do you get repeating? Just type a whole bunch of sixes until you run out of space. So hit 0.2916, just keep typing sixes, and then divided by negative ln 1.034. Okay, and this is what it comes out to be. 36.85. These are periods. So if it's periods, you round to the nearest period. So round up to 37. Okay, so I want 37. All right, and now answering the question of how long. Okay, how long? We have 37 periods. And it said it was semi-annual, right? this athlete, he or she wants to take it out twice a year. So 37 periods, 37 divided by 2 is 18 and a half years. Okay. So under this scheme, this athlete puts down 2,500,000. That person can take out 120,000 every 6 months for 18 and a half years. And then the bank account is all drained. Okay. All right, so I'm actually done with 6.4. The reason why I was going faster is because I didn't show you all the calculator stuff. I will assume that you can do that. Okay. I will do a little bit of 6.5, not much, but enough to get you started with it and to get you started on the table. Because again, I want to give you at least 1 week before the test rather than just 2 days. If I wait until Tuesday, you'd only have 2 days to get you started. So 6.5, let me show you what the topic is. And believe it or not, it's really the same formula. There's a reason for that. So I'm sneaking in a little bit of 6.5 today. Again, so on Tuesday, if you want to have any questions on any section from 6.1 to 6.5, you can bring it up. And then Thursday's test, same thing. I'll let you ask questions, but if nobody asks questions, we can just go ahead and start early. Okay. So 6.5 is on loans and amortization. They give you a new formula. You don't need it. It's a variation of this formula, which is the same as 6.4. Okay, so maybe I'll just write here 6.4 and 6.5. Okay, this is correct. There's nothing wrong with it. If you do a little bit of algebra, you can make it look like this, but you don't need it. Same formula. Okay, so what happens when you take out a loan? Okay, and what is amortization? That's you take out a loan like a home loan or a car loan. Okay, and you end up with something called an amortization table like this. So I'll go over this example with you a little bit more slowly, but see if you can figure out, make heads or tails out of this. In reality, when you take out a home loan, a lot of home loans are 30 years or maybe 20 years, 15 years. It's almost always monthly. So it's 30 times 12 is 360. Imagine this going down 360 rows. Okay. Car loan is what? 3 years, 4 years, something like that. So let's say 4 years times 12, this will go down to 48. Okay. For our purposes, we just have 4 or 5. I mean, if you know how to do it after 5, you know how to do it after 48. And of course, they would have their computer spreadsheets to do these. Okay. Now, what happens in a loan? Okay. So let's say you want to buy a car. Okay. Car is, I don't know, $30,000. You say, I can't pay $30,000. Okay. So what happens a lot is you make a down payment and then you borrow the rest. Okay, so $30,000. I can put down $5,000 and the other $25,000 I'm borrowing. Okay. Right. So the bank or lending institution or the car dealership itself, whatever, will lend you the money. Okay. Then you promise to pay back a certain amount each month, normally, right? Until it's all paid up. Okay. So if you stop and think about it, let's say it's a bank. The bank is actually taking out an annuity on you. Okay. So think of 6.4. The situation is actually backwards. In other words, where the bank is taking an annuity on you. Okay, so remember what I said? This would be, I plunk down a big amount of money. Okay, like that athlete, $2.5 million. Okay, and then every 6 months, make regular withdrawals until it's all gone. Okay. When you're taking out a loan, it's like the bank is doing one of these present value annuities on you. Okay, so the bank is lending you a large amount. Okay, and then when you pay the bank every month, right? That's sort of like the bank is making regular withdrawals on you. You see, it's kind of reversed, but when you make the payment, that's like the bank is making regular withdrawals. In the meantime, the bank is earning interest, right? Until it's all paid up. Okay? Which of course naturally means you end up paying more because you're paying interest on it. Okay, so you're borrowing at 5%, 4%, or whatever the bank is taking one of these things out on you. So it's lending you, $20,000. It's going to end up getting back, I don't know, $25,000 because it's earning interest. So the bank is taking a present value of an ordinary annuity on you. Therefore, it's the same formula. Okay. Same thing for a house. Only for a house, you're having much bigger numbers, right? You're borrowing $1 million to buy a house nowadays or whatever, right? Okay. All right. The bank is lending you $1 million. And then when you make the regular payments every month, that's sort of the concept where it's like the bank is making regular withdrawals all along, earning interest until the loan of 30 years or 15 years or whatever is all paid up. In the meantime, the bank is making much more money. You end up paying much more at the end for the loan. That's the way it always is, right? So you borrow 20,000, you end up paying 30,000. Okay, for a house, you borrow $1 million, you end up paying sometimes maybe even 2 million. Okay, that's the way it always works for loans. Okay, in a nutshell, it's the same formula. Okay, so I'm going to show you one problem from 6.5, and then I'll show you the table, and then I'll quit. And what time is it? I don't have my watch. It seems like it's about 5:15ish or something like that. Okay. So in other words, 6.5 is really the same formula, which means you should be able to do all of 6.5, except maybe for that table. And that's what I'm going to try to show you. Okay, so let's see, where am I? Okay, so 6.5. Let me see if you correspond here also. Okay, the homework is 3 through 12. Yeah, I think we can keep that. So yeah, let me show that to you for those of you who don't have the book and don't plan on getting it. 409. So what do we have? 3 through 12. Try to make it better for focusing. Okay, 9, 10, 11, and 12, we actually have to make the table. So that's going to be harder, of course. Okay, and I'll show you an example today, and then I'll do a couple next time. Okay, but to actually work the problems out are very similar. All right, so let me see what I wanted to do. Okay, 6.5. Okay, my number 6. For equipment upgrades, a business borrowed $400,000, 8% compounded semi-annually for 5 years. What are the semi-annual payments? Okay, same formula. The $40,000 is the AN. Okay, 8% semi-annual. Divide by 2. 5 years. What's the N? 5 times 2, 10. What are the semi-annual payments? Okay. So A sub N is 400,000. It's at 8% semi-annually. That means I is 0.04. N is 10, 5 years, 2 times a year, semi-annual. Okay, so what are the payments? So this is typically the way these kind of problems work. 400,000 goes here. You're solving for R. That's the AN. Okay, 1 minus 1.04 to the negative 10 divided by 0.04. This is another one of those where you want to use your answer button, preferably. Okay, and if you don't, you'll have to just write down every single digit for greater accuracy. Okay, so this comes out to be 8.11 and a lot of other stuff. This fraction. So divide both sides by 8.11. So R is 400,000 divided by 8.11. Again, if you have the answer button, just hit the answer button. If you don't, put every single digit. Okay. $49,316.38. Okay. So that's what's happening.
So this is a situation where you borrow 400,000, a business, let's say, and then the way the loan works is you pay 8% compounded semi-annually for 5 years. Okay. So every 6 months, that's the amount you have to pay. Right? So that's all. Same formula. The problem's finished, but I'll dig a little deeper. What's the total amount that you paid back from this loan? Right? Well, you multiply by 10. It's easy to multiply the 10 by 10. Do you remember the shortcut multiplying by 10? All you have to do is move the decimal over one spot, right? So it'll be $493,163.80. So I'll just say 493,000. So what did you borrow? 400,000. What's the total amount you pay back? 493,000. That's the way loans always work, right? You end up paying more for the privilege of borrowing the money. Okay. All right, what time is it? 20. Okay, the last thing I want to show you is the table. And so the last 4 problems involve the table, 9, 10, 11, and 12. Okay, so I'll show you how to do the table. I'll actually do a couple of them next Tuesday. But how do you do this table thing? Something called an amortization schedule. It's on page 406. So again, copy this, put this on your cheat sheet. So under this scheme, amortization schedule, the loan is $10,000. Interest is 10% paid in 5 equal annual payments. Okay, compounded annually means N is 5 and I is 0.1, right? Okay, so throw it in the formula. $10,000 is the A sub N, 0.1 is the I, 5 is the N. Okay, they did it. It's 2637.97. It's the regular payments. Okay, I mean, it's just using the same formula as this. It's rounded to the nearest penny. Okay, so 2637.97. So notice the table. It says we're going to pay it 5 times. So 1, 2, 3, 4, 5. 2637.97 for all of them, except maybe the last one. Notice the last one in this case is a little bit different. 2638. It might be exactly the same. It might be a little bit higher. In this case, it's a little bit higher. It might be a little bit lower. Okay, I think I'll show you an example of each. Okay. Now, how come it's not exactly the same? The reason why it's not exactly the same is because in our money system, we have to round off. Okay, now, you know and I know that when you punch this out, it's almost never exactly 2637.97, right? Maybe it's 2637.9714285, right? Or maybe 2637.96932384316 or whatever. Okay. If you could literally have money that has every single digit, these would always match. Since there's a rounding off, you're probably going to be off by a little bit. So you can see in this case, we're off by 3 cents, I guess. Okay, so how do we work the table? Okay, so try to take notes on this and follow along. So you have $10,000, right? That's how much you're borrowing. Okay, you pay 2637.97. Any of you who've taken a loan before, you may know this. You don't get to subtract the 2637.97 first, because the first thing you have to pay is the interest. In this case, it's 10%. So first, you have to take off 10% of the 2637.97. I'm sorry, right. You take 10% of 10,000. 10% of 10,000 is 1,000. So you subtract that. You first have to pay the interest. Then you subtract this minus this, giving you this. Okay, and if you want, I'll go ahead and write in my book. Okay, this minus this equals this. Does that help? All the way down. This minus this is this. This minus this equals this. If you don't want to write in your book, just follow the notes there. Okay. This is the amount that you get to subtract. So 10,000 minus 1637.97 is this. Okay. So if you take this and subtract, so I'm putting a minus sign. 10,000 minus 1637.97 is 8362.03. Okay, 10,000 minus the 1637. Okay. Then you keep doing that. Second period, same thing, 2637.97. But first you have to pay 10%. Okay, the interest rate is 10%. 10% of that, rounded off, is 836.20. So the amount you get to reduce the balance by is the difference between this and this. So subtract that minus that is 1801.77. That's what you get to subtract. So 8362.03 minus that is 6560.26. And you keep going. Same thing. Make the payment, pay the interest, figure out the balance reduction, new balance. Okay? Now, one thing you may notice, as time goes by, are you paying more or less interest? You're paying less. How come? Because as you pay off the loan, there's less balance there. So that means the interest is going to be less also, right? So 10% of 10,000 is bigger than 10% of 8362, which is less than 10% of 6560, right? So you pay less interest as time goes by. And that's the way loans always are. When you get a car loan or a home loan, the most amount of interest you pay is at the beginning. And then at the very end, you pay very little interest and most of it goes to balance reduction. Okay, so same concept here, same concept here. Now, what about that last calculation? So here's how the last calculation works. So the 2637.97, it's going to be the same thing except for maybe the last one. The last one might match, but we don't know yet. So how do I do the last one? So here's the way the last row works. Okay, so pretend you don't know this. Take 10% of this, round it off, 239.82. Okay. Notice that that number matches this number. That's always going to happen. In fact, I'll go ahead and put this at the very last row. These are equal. They have to be equal, right? Because if this is the unpaid balance, you're going to end up with paying off the loan. So you have to pay off 2398.18 in order to end up with zero, right? So the way you play the game is, again, pretend you don't know this. Take 10% of this, put it here. Copy this one right over here. So that, you know, that minus that is zero. And now you add these two numbers. So if you add 2398.18 plus 239.82, you end up with this. And there you go. And here are the totals. So you ended up paying, just add this up, 13,189.88. This is the interest, balance reduction. Balance reduction should make sense. You started with 10,000, you reduce it to 10,000, so it's all gone. Okay, so that's the amount you paid in interest. Okay, so you borrowed 10,000, end up paying 13,000 plus. That's the way it always is when you take out a loan, right? Okay, so you're going to be doing this for homework. So those were the last 4 problems, I think. So see if you can make heads or tails out of that. I'll do it on Tuesday, but at least, you know, you've seen it. So you have a week between now and the test to see it. If I wait until Tuesday, you only have 2 days. So at least you've seen it once. I will demonstrate probably, you know, 10 and 12, the even ones that are there, so you can see how they work. Okay, but that's the concept. So maybe I'll just run through that one more time, then I'll stop and give you the quiz. Okay, so after you do the calculation, right, plug into the formula, and the payment was, where'd it go? 2637.97. You put the 2637.97 all the way down except for the last one. The last one might be the same. It might be a little bit bigger, might be a little bit smaller due to rounding off. Okay, take the interest. In this case, it's 10%. It's not 10% for every problem, right? It might be 7% or 5%. If it was 7%, I take the 7%. Okay, put that here, subtract these two, and then take the 10,000 minus this amount, gives you this. do the same thing. 10% of that, subtract, and then subtract 8362 minus 1801 gives you that. Keep doing that until the last one. Last one, you don't know the payment yet. Take your 10%, copy this one. So this one's always 0. It's got to be 0. You pay it off. Okay. And then you add these two to come up with this. And this one, you just add them all up, right? Just add all these numbers, add all these numbers, add all these numbers. Okay. I'm holding up the book and it's too heavy. So I'm going to take this down now. Okay. All right. I think I'm done, folks. So any questions, you can unmute yourself and put it in the chat. And if not, we'll go straight to the quiz. Okay. All right, I don't see anything. All right, so it's quiz time. So get your cell phones out or be able to do a screenshot of the quiz now, please. And here we are. Okay, number 1, find the simple interest and the new balance if $5,000 is invested at 3% for 5 years. That's section 1. Okay. Question 2 is section 2. Find the new balance and the interest if $3,000 is invested at 8% compounded quarterly for 6 years. And they give you a hint to find the interest, subtract the principal from the new balance. So each one, there's 2 answers. Number 1, there should be 2 answers. Okay, the interest and the new balance. And number 2, you have the new balance and also the interest. So you should give me 4 numbers total. For number 1, the new balance and the interest. Number 2, the new balance and the interest. Number 1 is from section 1. Use the formulas from there. Number 2 is from section 2. The formulas are all there. Okay, I'll hold it just a little longer. You can go ahead and get started. And then I'll make your breakout rooms. And you have until the rest of the class, so 5:55. But if you finish early, you can leave just like before. Okay, I will now assume that everybody has this one way or the other. So I'll make this disappear and go ahead and keep working. Let me set up your breakout rooms. Again, put your first and last name and the first and last name of everybody else in your group also. Okay, you're going to be in groups of either 3 or 4. Okay, so let me get that. Okay, you should have an invitation to join your breakout group, please. So everybody, please join your group.
Hey, Lucas, can you join the group?